In this video, you're going to learn how a generator works. In this case, it's an AC generator, a generator that transforms mechanical energy into electrical energy, in this case, alternating current. An AC generator works on the principle of electromagnetic induction. In electromagnetic induction, you need to have both a magnet and a coil of wire. Now, one of these things need to move. Either move the magnet or move the coil of wire to produce an electric current. An AC generator has an armature. See the points labeled A, B, C, and D? It is a rectangular coil of wire with many turns wound around an iron core, with a shaft sticking out to rotate it. You also have a strong permanent magnet with both north and south poles surrounding it. The magnet has a hollow center to allow the coil of wire to rotate inside of it. There are two slip rings, S1 and S2, connected to the armature. Two brushes, B1 and B2, provide an electrical connection, in this case connected to a meter to show us the electrical current produced. When the armature rotates between the poles of the magnet, electromagnetic induction happens. This produces the electrical current. If you look at the meter, you can see that the current is an alternating current because the needle bounces left, right, left, right. In other words, the direction of the current alternates. This is how electricity is produced. The same thing happens in a giant power plant. It's just that the generator there is a lot bigger. Also, in a power plant, you don't have a person turning the shaft on the armature to make it spin. You need to find another way to get that spinning to happen. In that case, it's a turbine. So let's review how that works. All our electricity starts as some other form of energy, which means all of our ways to generate electricity are just fancy ways of converting one type of energy to another. In most cases, the type of energy being converted is heat. Take a look at this pie chart showing the breakdown of types of global energy production. You'll see that the vast majority of methods we use to gain power are just ways to get water hot enough to turn it to steam. These are our thermal power plants. Most of the thermal power plants in the U.S. burn fossil fuels to produce that thermal energy or heat. But there are other alternatives too, such as nuclear energy that also generates heat.
Generating electricity requires a fuel source. At this plant, the fuel source is coal, which arrives mainly by a barge but also by rail and truck. Each barge delivers 1,500 tons of coal, enough to keep the plant running for a couple of hours. The plant uses about 21,000 tons of coal each day, so over 1 million tons of coal is stockpiled next to the plant. Large fans add warm air to the powdery coal and blow it into the boiler. The boiler has miles of tubes filled with high-quality water. Once inside the boiler, the coal ignites, releasing energy and generating intense heat that changes the water inside the tubes to hot, dry steam. The temperature of the steam is now about 1,000 degrees Fahrenheit. This process generates thermal energy, which is transformed to mechanical energy at the turbine, which is the next stop on our tour. High-pressure steam, now 1,000 degrees Fahrenheit at 3,500 pounds per square inch, is piped from the boiler to the first in a series of turbines. Here it expands between layers of turbine blades mounted on the turbine shaft. The steam loops back to the furnace, then onto the second turbine. In this process, the steam turns the series of turbines 3,600 revolutions per minute, providing power to the generator, the last in the series of machines. The generator continuously creates an electrical charge of 34,481 amps at 18,000 volts of electricity. From here, the electricity leaves the plant and begins its journey to customers.
Now close the window with this video so you can finish the lesson on Nearpod.com.